Hi, you guys. Okay, so today I'm going to talk to you about how to solve a problem if you are given the mass of something and the volume of its solvent. How do you solve for the hydroxide, hydronium, pH, or pOH value? So I've been given a problem like this, and so it's in your notes, and so it's right here. So I'm going to go ahead and say, what is the pOH? What is the hydroxide, hydronium, pH, and pOH if you have 95.2 grams of potassium hydroxide in a 450 milliliter of water? So we want to find these values right here. I'm going to write here OH, whatever that value comes out to be. I'm solving for hydronium ion concentration, whatever it comes out to be, pH of my solution, and the pOH of my solution or substance that I have. Okay, so that's really what I'm trying to solve for. I can't solve any of these problems. Notice that this is a strong base that I have. A strong base, if you have a graduated cylinder, if you have a flask or a beaker or something, and you put potassium hydroxide in it. Remember, potassium hydroxide is a very strong base. So this potassium hydroxide will dissociate 100%, or at least we're going to assume that it dissociates 100%. That means that the potassium in the hydroxide, all of the potassium in the hydroxide in this solution will separate from one another or dissociate from one another. So whatever, let's say you have a certain molarity of this solution of potassium hydroxide. Well, that is going to be the molarity of your potassium, whatever molarity it is, as well as the hydroxide. So your molarity is going to be the exact same as your solution, okay? So because it is a strong base, remember that your strong bases are usually in group 1 and group 2. In group 1, you have 4 strong bases, which are lithium, sodium, potassium, rubidium, and cesium, which is 5, actually. 5 strong bases. And then in group 3, you have calcium, strontium, and barium. So those are your 8 strong bases that you have, okay? So in this case, I need to find the molarity of my solution. I need to get the concentration so that I can solve for these problems. So the way that I'm going to get the concentration is that I have 95.2 grams of potassium hydroxide, and I'm going to convert it into moles, because remember, molarity is moles over liters. So I'm going to convert it into moles. So I want to get to the molar mass for my potassium hydroxide, and that is 56.11 grams of potassium hydroxide to every 1 mole of potassium hydroxide. Now that's great that I have moles on top, but I still need liters, which is over here. So, but that's how much I have of my solvent. So it's 450, and you want it in, this is in milliliters, so you want to convert it to liters, 0.450 liters of potassium hydroxide. Okay. Now, if I've done this correctly, my grams of potassium hydroxide would cancel, and what I have left remaining is moles over liters of my solution. And when I plug that into my calculator, and it's a simple calculator calculation, I get 3.77 molarity, okay? And this is of molarity of potassium hydroxide. That's what's my molarity. But understand that this is 100% dissociation because it is a strong base. So what's going to happen is that this is also the molarity of your hydroxide, okay? So that's your molarity of your hydroxide. So we're going to write that here, 3.77 molarity. Because you are talking about concentration, so you need to write molarity, you need to write your units. Now, after this, you know how to do it. If I want to solve for a hydronium ion, well then I have the Kw value that I can use. And this is really hydroxide ion concentration times hydronium is equal to my Kw value, which is 1 times 10 to the negative 14. Okay? And I get from here, and I can substitute 3.77 molarity. Okay, so I'm going to divide by 3.77. And when I do, my hydronium ion concentration in this case is 2.65 times 10 to the negative 15th molarity. Okay, so in this case, my answer is 2.65 times 10 to the negative 15 molarity. Now I can use this to calculate my pH. So my pH in this case would be the negative log of my hydronium concentration, which is 2.65 times 10 to the negative 15th. Okay, so negative log 2.65 to the negative 15. And when I do, my pH value is 14.58. That makes sense because I'm dealing with potassium hydroxide. I would want my pH to be on the high range, the high part of it. And this is going over than 14, and that is fine. So this is my pH would be 14.58. Remember, pH doesn't really have a unit, so you're not going to put anything. And now if I want to get my pOH, remember this relationship. So if I have my pH here, 14.58, I'm going to try to find my pOH value. And this is 14. So 14 minus 14.58 is going to give me, in this case, I'm going to get a negative 0.58. Okay? And so my pOH value is a negative 5.8. Now you want to keep this in mind because if you have a scale, if you have a pH meter, okay, if you have a pH meter that goes from 0 to 14, keep in mind, so keep in mind that over here from 0 to 7 right here, from 0 to 7, that this would be the acid. And from 7 to 14, that would be the base for your pH meter. And this is where you have a high hydronium concentration. This is where you have a low hydronium concentration. If you're just going for your pOH, now you're trying to find those hydroxide ion concentrations. So from 0 to 7, keep that in mind, from 0 to 7, this would be considered the base, and from 7 to 14, on our pOH scale, would be considered an acid. So if I give you the pOH happens to be, I don't know, 10.7, then clearly 10.7 would be somewhere over here, so that would be an acidic solution. If I give you my pOH happens to be 2.7, then that is clearly a base. My pH right here, if I give you a pH that is equal to, again, 10.7, because I'm using the pH scale right here, if it's 10.7, that would be considered a base. And my pOH, on the other hand, would be 2.7, which would be right here, an acid. And I've already talked about how to read this scale before. I just wanted to do a quick review with you because this negative, for my pOH value, this negative 0.58 would say that it is definitely a base. That makes sense that it would be a base because look, I'm dealing with potassium hydroxide. Even if you look at the pH turns out to be 14.58. So if we're looking at the pH scale, this is an acid right here. It's a base right here because it's very, very basic. So 14.5H for my pH also confirms through the pH scale that I am talking about a very strong base. Okay, so that is if you have a base in your solution, then your hydroxide concentration, you can find your hydroxide concentration, and then from there go on and do your other log stuff. But what if I give you an acid? It says, what is the hydroxide, hydronium, pH, and the pOH if you have 95.2 grams of hydrochloric acid in 450 milliliters of water? Well, once again, since we're trying to find those, I'm going to go ahead and write that stuff down. Because I am trying to find that on the side. I am trying to find that for each of the problems that I have. Okay, so that's what I'm looking at. I'm trying to fill those blanks in. So in this case, I am given an acid. Okay, I do need to find the molarity or the concentration in order to figure out the hydroxide and the hydronium ion concentration. But because I am given a strong acid, and now once again, if I have a beaker full of this acid, okay, this beaker that's full of hydrochloric acid, once it is in water, solvation occurs, I will have the hydrogen and the chlorine, they will split up from one another again, and because they will split up with one another, they will dissociate completely. And that's what's going to be left in my water. So in this case, whatever, because it is 100% dissociation. Same with the potassium hydroxide. Remember, because it was a strong base, it was 100% dissociation. Okay, so 100% dissociate. So does this. Because I have that, then whatever molarity of my hydrochloric I have, that is the molarity of my hydrogen that I am going to have, as well as chlorine. Okay, that is the molarity that I'm going to have. So what happens? How do you find the molarity of this problem? Well, same way, 95.2 grams of hydrochloric. And we want to find divided by its molar mass, which is 36.46 grams of HCl, and then 1 mole. Okay, and that's it. So now remember, molarity is moles over liters. So we have moles and we don't have liters, but we do have the volume of our solvent. So again, we're going to write 450 liters of hydrochloric acid. Okay, so my grams will cancel, and I will be left with moles of hydrochloric acid over liters of hydrochloric acid, which is my molarity. So when I plug this into my calculator, I should get 5.80 times 10 to, nope, I do not get that. It's 5.80. That is my molarity of HCl, of my hydrochloric acid. This is 5.80 molarity is also true for my hydrogen ion concentration. Okay, so hydrogen ion is the same thing, remember? That it is the same thing as hydronium ion that I have. Okay, so I'm going to write in here 5.80 molarity of my hydrochloric acid of my hydrogen ion concentration. Now, using the same principles as the Kw value, I have hydronium ion times hydroxide is equal to your Kw value, which is 1.0 times 10 to the negative 14. Okay, so this 1.0 times 10 to the negative 14 is your Kw value, And of course, right here, you're given your hydronium ion concentration, and this is H3O plus for my hydronium ion concentration, and that would be 5.80 molarity. Now, using the process of algebra, that you can find the hydroxide ion concentration. So that would be that would be 1.72 times 10 to the negative 15. And you are using the correct number of significant figures. So in this problem, since there's 3 and 2, you want to use up to 2 significant figures, so I would not need this. Okay, so this would be 1.7 times 10 to the negative 15 molarity. And I can find my pH now from this by using, or I can find my pOH. I could find my pH also. It doesn't make a difference. I could just use this value. But I didn't, in the other problem I found the pH. So I'll go ahead and use this value and find the pOH first. Okay. It really doesn't make a difference which one you find. You can use any process that you want to find any of these pH or pOH problems. So I've got here negative log of 1.72. And I get my pOH in this case is 14.76. So my pOH is, in this case, 14.76. And there is no unit for your pH and pOH. And then, of course, you have this equation. Oh, sorry. Of course, you have this equation that you can solve for pH now. And so this would be, pH would be equal to 14 minus 14.76, which would give me negative 0.076. Okay, so that would be my pH, and of course it's a negative, so I need to write that negative sign. That makes sense because if I'm looking at my pH right here, 0 and 14, my pH is 0.76, which is somewhere around here. This is very acidic. That would make sense because I am using a very strong acid, which is hydrochloric acid. Okay, if I'm using my pOH, 0 to 14, this would be my base, this would be my acid. My pOH in this case is 14.76. Again, 14.76, that is in the acid section of my pOH. So this would be a very strong acid that I'm using. And that totally makes sense. Okay? So I think the biggest thing that you guys need to remember out of problems like this is when you find the molarity, you're using the same substance. So you really don't have to use moles or try to balance the equation. You're just trying to convert this substance into moles and then divide it by the volume that you have to get the molarity or the concentration of your solution. And because this is a strong acid, it will dissociate completely. If I give you a weak acid or a weak base, this solution doesn't work because remember, your weak acids and your weak bases do not dissociate completely. Sometimes they break apart into positive and negative ions, but sometimes they don't. So we don't know which one happens, and we would have to use a different process for that. But for strong acids and bases, it's pretty easy. When you find the molarity, realize that if you are working with an acid, then you are getting, because that hydrogen breaks up in your solution, you are actually getting the hydrogen ion concentration. Okay, and once you understand that, then it's pretty easy, I think, for you to solve this in every case. Okay, so I hope this explanation helped you, and now you understand a lot better how to solve these problems. Okay? All right, talk to you guys later. Bye.